All right, so welcome back to the fluid mechanics section of the Civil FE exam review. Today we're going to be looking at fluid properties, and so I have a few practice problems for y'all to go through. And so again, units are going to be key for us. And so let's go ahead and dive right in. So number one says a fluid has a density of 1,000 kilograms per meter cubed and a dynamic viscosity of 0.1 Newton seconds over meter squared. What is the kinematic viscosity of the fluid? Okay. So what information are we given? Given the density. We're also and the dynamic viscosity. I'm just gonna abbreviate. Okay. What are we trying to find? Well, we're trying to find kinematic viscosity. Okay, so what formulas do we need? Well, I don't know by heart the formula for kinematic viscosity, but I know that's what I'm trying to find. So I'm just going to do a quick search. All right, so I do a search for kinematic viscosity. All right, here's what comes up. Kinematic viscosity is the symbol kind of V. So V is equal to, okay, let's make sure we have some other variables that we'll need. What is this mu? Well, the handbook is going to tell us what this top mu is. So mu is the absolute dynamic viscosity of the fluid. So we have mu. So this is mu. All right, and then it's all over density. And we know that from this formula, density of the fluid is the P. It tells us in the handbook. Okay. So this is our P. Okay, so now it's just a matter of making sure our units make sense and going from there. So we have our dynamic viscosity, all right? But if I take, I'm just doing kind of like a, let's just write it out for simplicity terms. So if I have a point, this equals 0.1 Newton times seconds over meters squared, all divided by, so that was our mu, all divided by our density, which is 1,000 kg per meter cubed. Okay, so what's the problem here? The problem is our units don't cancel out. All right, so we have kilograms over meters cubed. So meters. Okay, we got this Newton seconds going on. So is there a conversion that we can make with Newtons to get this thing to be in kilograms or something to cancel out more units, right? So I'm going to look up what Newton equals in the unit conversion section, because I'm sure that there is a conversion for this, right? So I just jump to the conversion section. And we learn that 1 Newton is equal to 1 kg times our meters over second squared. So 1 Newton is equal to 1 kg times m over s squared. All right, how does that help us out here? All right. Well, it helps us cancel out more units. So once we convert this again, right, we have 0.1, and now I'm substituting my newtons, right? This is what I'm substituting out. It's newtons. Okay. For this. So 0.1 times 1 kg m over s squared. Okay. Now, going back to my other unit times s all over meters squared. And then that's all over 1,000 kg over m cubed. All right. So our units, they're going to simplify to equal 0.0001 meters squared over seconds. So our kilograms will cancel. This unit just cancels to a s, right? And then we're left with this meters cubed is going to be multiplied by meters, so it's going to be meters to the 4th over meters squared. It's going to give us our meters squared over a second. So that's how our units are going to cancel. So we are left with A. So just making sure you understand your units, making sure you understand what variables they give you, and then just writing it out, listing out everything, and don't worry about, how confusing sometimes the units get. Just take your time as you're practicing. And so this stuff will come much faster to you once you actually have done multiple problems of this. So, all right, let's look at number 2. All right, so this one says, calculate the density of a fluid with a mass of 4 kilograms and a volume of 0.002 meters cubed. Right. All right, so this one seems pretty straightforward, but we're going to go through it. So choose a different color. I'm going to go with green. So we're given a mass, right? It's 4 kilograms. We're given a volume 0.002 meters cubed. we're trying to find density. Okay. So if we're trying to find density, what formulas do we need? I'm going to do control find and search for density. And 100 different things come up. So this is something that you should know, but again, you want to be in the correct section, right? So as we're going through different problems, density would be looking at density from a fluid mechanics perspective. All right, so it says density is equal to the change in mass divided by the change in volume. So there is no change in density is equal to the change in mass divided by the change in volume, which is equal to mass final minus mass initial over volume final minus volume initial. There is no change, so we're just going to say that that equals just our mass divided by our volume. Okay, so let's get started. So if we have mass, all right, 4 kilograms, we have volume 0.002. If we divide those, it looks like we'll have everything we need, and our answer is in kilograms over meters cubed, which is perfect. So this is going to equal 4 kg divided by 0.002 meters cubed. And for this one, we get 2,000 kilograms per meter cubed, or C. Alrighty, let's look at number 3. This one says, calculate the velocity of a fluid flow with a volumetric flow rate of 0.02 meters cubed per second and a cross-sectional area of 0.005 meters squared. All right, so go through this one. What information are we given? Well, we're given the flow rate, .02 meters cubed per second, and we're also given area 0.005 meters squared. All right, so what are we trying to find? Velocity, V. All right, so it's like we have the answer shown, but still work through this. So the formula, what formulas do we need for this one? So if I'm given flow and I'm given an area and I'm searching for velocity, sure there's a formula in here that will get me to an answer. So looks like it's here. Q is equal to A times V, where A is our cross-sectional area of flow which we have. And Q is the volumetric flow rate. So the last thing we need is going to be our velocity, which should be in meters per second once everything cancels. So let's go ahead and solve. So Q is equal to A times V. And then this transitions to Q over A is equal to V. All right, we have Q, which is 0.02 meters cubed per second. And we'll divide that by our A, which is 0.005 meters squared. And once you do those, you should get 4 meters per second, or A. Alrighty, that concludes this section of the fluid mechanics review. The next section, we'll be looking at fluid statics.